Hello guys, it's me Jay and welcome back to another video. And in this video, we will talk about integration. We will learn the application of integration and some of the important rules in integration. Okay, but before that, let's talk about the application of integration. Integration, it is a mathematical operation which arises in two contexts. The first one is integration is also known as anti-differentiation or anti-derivatives. And the second context is that integration is known to compute for the area under a graph of a function or an area under a curve. Okay, so when we say integration as anti-derivatives, if we have f prime x as the derivative, then the fx or the function of x, it's the anti-derivative. So like for example, if we want to differentiate 2x, okay, with respect to x, that would give us what? 2, correct? If you want to return this function into its original form, then we have to integrate this function. So therefore, if we integrate 2 in dx and we have a given limit from a to b, that would give us 2x, okay? And that is the original function. Hence, it is known as anti-derivatives or the reverse of differentiation. Now, when we say integration as area under a curve, okay, so we usually use integration in computing the area of an irregular geometrical figure. Okay, so unlike square, circle, we have already the formula, diba? In computing the areas. No, we are familiar with the formula, which is just the length times the width for the rectangle, and for the circle, that is pi r squared. However, what if we have a curve, okay, this area here? If we want to compute the area, okay, in this area here, so we don't have specific or we don't have formula, right? So in that case, we apply integration. Now, the concept of integration is that we divide the region into an infinitely small rectangle. Okay? So if we look at the curve, so ang mangyayari dyan, we divide it into very small rectangle, okay, in which the width is in terms of the derivative of x, so that's infinitely small. Okay? And then we add the area of this rectangle. So basically in integration, we are doing approximation. We approximate the area of the curve by adding or by summing up the area of rectangle in that region. Okay? Then the smaller the area, the most accurate the area would be. Okay, we have here a figure. No? So if you want to compute the area, this area here, bounded by this curve and this line, so if you want to compute the area, this area, so we don't have an existing area or formula to compute for this area here, correct? So in that case, we apply integration. Now, the basic concept of integration here is that, again, we divide this area into rectangle. For example, we have rectangle, we have this rectangle, correct? And we also have this one. But the smaller the rectangle, the accurate or the more accurate the area of this curve would be. So if you try to look at the rectangle here, parang if we divide it into smaller rectangle, so the accurate yung occupancy niya sa curve. So ma-occupy niya ang curve accurately, okay? So what if we divide it into a much smaller rectangle here? Okay? So therefore, mas nagiging accurate yung computation ng area. So the concept here is we sum up the area of each rectangle. Okay, so we compute the area of each rectangle, then we sum it up, then that is the approximation of the area of this curve. Okay, that is the concept of integration. Okay, so let's discuss on the parts of an integration. So we have here, this is the symbol of integration. Okay, that is the integral symbol. Then inside we have the integrand. It's what we call the integral, or it's the function of any variable. It could be function of x, it could also be function of y, then we have to derive that into its function. Okay, that's what we call the integral. Now, in this lesson, we will talk about indefinite integration. So therefore, we have a arbitrary constant c. Okay, so we have two types of integration. We have definite integration if we have a certain limit in our integration, and we have indefinite integration if wala tayong limit in our function. So we retain the constant c in indefinite integration. Now let's tap on the rules in integration. So we have here the most basic rule of integration, that is the integral of r du, in which r here, that is constant. Now we have, if you integrate constant with respect to any variable or du, okay, now that is ru plus c. Okay, remember this equation in which r here is constant. Now for second rule, if we have u raised to r du, the integration of that is in terms of u raised to r plus 1 over r plus 1 plus c. So take note, our r here should not be equal to negative 1. Remember that one. If negative 1 ang atong r, so if negative 1 here plus 1, that will give us 0 value in the exponent of our u. Okay? So our r in this case should not be equal to negative 1. And our u here, that is an any function, or let's say that's a function of x. It could be function of z or a or b. Okay, and du here, that is the derivative of u, the derivative of our function of x, or that is our f prime x, or that is our f prime y, f prime z, so depending on the variable or depending on the given variable. Okay, so let's try to solve problem. So we have problem number 1, we have the integration of 5 dx. What rule that can be used in this type of equation? So we have the first rule, we have the integration of r du, okay, is equal to ru plus c. So our r here, our r, take note, is constant, correct? So our r in this case is equal to what? 5, correct? And our du is dx. So this one is the r, and this one is our du. So therefore, by using this rule, then we can say that our integration of 5 dx, that is equal to ru, that is just 5, and our u here, okay, that is the original form of du. Take note, our u here, that is x, correct? That is 5x, then arbitrary constant c. So don't forget the constant c here. Okay, so this is the integration of 5 dx. Now we have the second example. We have integration of 7x squared dx. Now take note, if we have constant 7 in the equation or in the function, then we can take 7 outside of the integral. So we can say that it is 7 integration of x squared dx. Okay, we can take 7 outside the integral. Okay, in this case, we have x squared dx na lang yung i-integrate natin. So what rule that can be applied into this type of function? So we have power rule. In power rule, again, we have the integration of u raised to r du is equal to u raised to r plus 1 over r plus 1 plus c. Okay, now in this case, our u here is what? Our u is equal to x, correct? Our u in that case is equal to x, and our r is 2. That is the exponent, okay? So therefore, we use this value and substitute in this form. We have u r plus 1 over r plus 1. Okay, so therefore, that is equal to u raised to r plus 1. We have u here, that's x. But take note, we have 7 outside of the integral. So it is 7, copy 7. Then we have u is equal to x. Okay. Then r plus 1, our r is 2. Then plus 1, that is 2 plus 1 over r plus 1. R is 2 plus 1 plus c. And that gives us 7x, 2 plus 1, that is 3, over 2 plus 1, that is 3, plus c. So this is now the integration of 7x squared dx. This is now your final answer. And then we have example number 3, we have the integration of 2 square root of x dx. So we can apply the first rule here since we have constant r. Okay, so we can take the constant 2 outside of the integral. Okay, we can rewrite the equation into 2 integration of square root of x dx. Correct? Now take note, we have radical here, square root of x. Now we can rewrite this into exponential form. So we know that our square root of x can be rewrite into x raised to 1/2. Okay, so please review your algebra. Therefore, we can see that it is 2 integration of x raised to 1/2 dx. Now take note, this is power rule. So by using this rule, we have the second rule, the integration of u r du is equal to u raised to r plus 1 over r plus 1 plus c. Okay, now in that case, our u is equal to, so the base, that is x, correct? And our r, exponent of our u, that is 1/2. So our derivative of u, so if we derive x here, then we get derivative of x, that's dx. So we can now use the power rule form, and that is, but take note, we have variable outside of the integration, so we rewrite 2, then we have u, it's x, raised to r, our r here, that is 1/2 plus 1 over, we have r plus 1 at the denominator, that is 1/2 plus 1, then don't forget the arbitrary constant c. So evaluate using your algebra, it's 2x, when we have 1/2 plus 1, we have 3/2, over, at the denominator, 1/2 plus 1, that is 3/2. Okay, then we have plus c. Then reciprocal, now we can simplify the fraction, okay, by getting the reciprocal of the denominator and multiplied it into numerator. But that is 2x 3/2 times the reciprocal of the denominator, that is 2/3. We have plus c, and then our answer here, that is 4/3 x 3/2 plus c. So this is now your integration of 2 square root of x dx. Then we have example number 4. We have the integration of 2z squared plus 1 over z squared minus 2/3. Then we have cube root of z dz. So take note, this is a polynomial function. We have 3 terms. Okay, so in that case, we can integrate the terms separately. So we can write our equation into the integration of 2z squared dz, correct, plus the integration of 1 over z squared dz minus the integration of 2/3. Then we have cube root of z dz. Okay, so we can integrate first the integration of 2z squared, or we can move 2 outside of our integral. So we can say that it's 2, the integration of z squared dz, correct? Plus, now take note, our variable here is in the denominator. So we can take z squared up to the numerator by changing the sign of our exponent. So we can see that it is z raised to negative 2 dz. The same as with y raised to negative 2, that is equal to 1 over y squared. Tama? From your algebra, we have x raised to negative 1 is basically equal to 1 over x. So now we have the third term. Okay, now we have 2/3, we have constant 2/3, so we can move 2/3 outside of the integral sign, that is minus 2/3, then the integration of, now take note, cube root of z is the same as with z raised to 1/3, correct? So that is z raised to 1/3 dz. So this is now our new form. So in that case, we can now apply integration to each term. Okay, and this would give us, what rule can we apply into this form? So we have power rule. We have power rule again, that is when we have u r du, that is equals to, if we have the integration of u r du, that is u r plus 1 over r plus 1 plus c. Now in this case, our u is z, correct? And our r here is 2, the exponent. Then our du here, that is dz. So this one is our du. So in that case, we can use the power rule in which our u, but to rewrite the constant 2, then u is z. Our r plus 1, then we have 2 plus 1 over r plus 1, that is 2 plus 1. Plus, now this is also a power rule. In this case, our u here is z, and this one is our r, and this one is our du, or just the derivative of our u. So we have u is z, our r is -2, that is -2 plus 1 over our denominator, we have -2 plus 1. Then we have minus, we have 2/3, that is 2/3. Then we have, this is still power rule, correct? So we can still apply u r du in this function. So we have our u, that is z. Our r, in that case, is 1/3. Our du is the derivative of z. This one, the derivative of our u, that is dz. So we have u, that is z, raised to r plus 1, that is 1/3 plus 1 over 1/3 plus 1. Then, don't forget the arbitrary constant c in the equation. Okay? So we have here 2z, 2 plus 1 is 3 over 3 plus, in this case we have z raised to -2 plus 1, that is -1 over -2 plus 1, that is -1, minus, we have 2/3 times z raised to 1/3 plus 1, that is 4/3 over 1/3 plus 1, that is still 4/3 plus c. Then simplify it further, we have 2/3 of z cubed. Then we have negative at the denominator, so we have positive in between or in the equation. So we multiplied positive times negative, then that would give us negative value. Then we have, take note, -1 in exponent in the numerator, then we can change -1 into positive by changing or by moving z raised to -1 to the denominator. So we have -1 over z. Okay, so you may not write the exponent 1. If you don't have an exponent here, that is understandable that it is 1. Okay, then we have minus. In this case, we have 2/3 z 4/3. Now take note, we multiply the reciprocal of the denominator. Since our denominator is fraction, then we get the reciprocal, that is 3/4, correct? Then we have plus c. Now our final answer in this equation, or in this integration, we have 2/3 z cubed minus 1 over z minus, now take note here, if we multiply 2/3 and 3/4, we can actually cancel 3. Tama? So we have 2/4. The remaining would be 2/4 z 4/3. Now to simplify, we have 2/4 here, or 2 over 4, then it could be reduced into 1/2. Tama? So we can say that it is 1/2 z 4 third, then we have arbitrary constant c. So this is now the integration of 2z squared plus 1 over z squared minus 2 third cube root of z dz.